Lesson 6-6, solving polynomial equations. So here's some different factoring techniques. This is kind of review from chapter 5, but I thought I'd include these in your notes. So the first thing that you should check for is, do your terms have a greatest common factor that you can factor out in front? Sometimes you can call this the distributive property as well. You would put your GCF out in front and then figure out what would be left in parentheses, thinking of the distributive property there. The second one is the difference of two squares. If you've got a squared minus b squared, you can split it up into two factors. These are some new formulas. The sum of two cubes. If you add a cubed plus b cubed, you can actually factor it into two factors. Or the difference of two cubes. Here's your formula. Perfect square trinomials are the trinomials that factor into two identical factors. So instead of writing a plus b times a plus b, you can write it as a plus b to the second power, or same thing here. And then finally we have the grouping method. This one might also be new to you. You use the grouping method when you have four terms, and it's helpful if the first two terms have a common factor and the second two terms have a common factor. So you factor out the common factor, and then you can rewrite them as a binomial times a binomial. That's how we want it to work out. Okay, so here's your factoring techniques. Keep those in mind. So example 1, we're going to factor 6x squared y squared minus 2xy squared plus 6x to the third y. Now the first thing I notice is that each number is divisible by 2, and every term has an x and a y in it, an x to the first and a y to the first. So I'm going to use the greatest common factor method first. The GCF is 2xy. Okay, so now I'm going to factor out 2xy and figure out what's left in parentheses. Well, 2 times 3 gives me 6, x times x gives me x squared, and y times y gives me y squared. So I'm trying to make this first term here. Then there's a minus sign. 2 times 1 is 2. I already have the x out in front, and so in the middle now I just need a y to make 2xy squared. And then I've got a plus. 2 times 3 gives me 6. X times x squared will give me x to the third, and then I've already got my y out in front. So here's our answer, 2xy times 3xy minus y plus 3x squared. That's as far as we can go with this one. Example 2, a to the third minus 4a squared plus 3a minus 12. Now, anytime you see four terms, you should immediately try the grouping method. Okay, so I'm going to group the first two, and I'm going to group the last two, and I'm going to try to pull out a common factor. Well, in the first group, there's a common factor of a squared. Both terms have at least an a squared. And if I bring a squared out in front, I'm left with a to the first minus 4 in parentheses. We get a to the third minus 4a squared. So you can check by multiplying to make sure that you've got it right. Then we've got a plus sign. Between 3a and 12, the common factor is 3. And in parentheses, I get a minus 4. 3a minus 12. There it is if I distribute. Okay, now what you're going to notice with the grouping method, if it works correctly, is that what you have in parentheses is the same factor, same thing, a minus 4. So we can bring a minus 4 out in front as our common factor, and then what's left over is this right here, what we put on the outside of the parentheses, a squared plus 3. So a minus 4 times a squared plus 3. Now, if you were to FOIL all of this out, you would actually get exactly what we started with, a to the third minus 4a squared plus 3a minus 12. Okay, so we know that these factors are correct, and you can check it by using the FOIL method. All right, example 3. How do we factor this one? Well, the first thing, again, that I noticed is that there's a common factor here between all of these terms. 2 goes into each number. 2 goes into 8, 2 goes into 24, and 2 goes into 18. They also have a common factor of x. So the first thing I'm going to use is the greatest common factor method, and I'm going to factor out 2x. Okay, so when I do that, 2x comes out in front. And now if I think distributive property, what do I have left here? I have a 4x squared. The 2 times 4 gives me 8. X times x squared is x to the third. Let's move on to the middle term. Minus 12x. 2 times 12 is 24, and x times x is x squared. Then we've got a plus. Our last term is just 9. 2x times 9 gives me 18x. So I've got it factored first using the greatest common factor method. Now, it is possible that what I have in parentheses could factor one more time. I've got a trinomial, 4x squared minus 12x plus 9. We need to think about, I guess, reverse FOIL here and see if this will factor again. So the 2x can hang out in front, but my question is, will this trinomial split? Now I've got some options for the 4 here. I could either use 2 times 2, or I could use 4 times 1. And my options for the 9 is either going to be 3 and 3, or 9 and 1. So I'm going to start by using 2 times 2 to make this first term here. 2x times 2x gives me 4x squared. Now my last two numbers, if we think of FOIL here, the first numbers give you 4x squared, that's what I've got. The last two numbers have to multiply to give me positive 9. But let's look at this middle term here. My outside product and my inside product has to add up, O plus I has to add up to negative 12. That must mean that my last two numbers are negative here, because if I multiply two negatives, I can also get 9. So let's think here. If I try 3 times 3, negative 3 times negative 3 will give me that plus 9 at the end. Let's check to see if our outside and inside terms will add up to negative 12. Okay, on the outside, I'm going to take 2x times negative 3, and that'll give me minus 6x. On the inside, I'm going to take negative 3 times 2x, and that'll give me minus 6x. So it seems like this works, and if you wanted to check, you could take 2x times 2x, that's 4x squared, negative 3 times negative 3, that's positive 9. FOIL everything out, and we do in fact get the correct trinomial here. So I've checked to make sure that it works. So my factors would be 2x times 2x minus 3 times 2x minus 3. There's 3 factors here. And if I wanted to kind of clean it up, I can rewrite my answer as 2x times 2x minus 3 squared. Since I used that factor twice, instead of writing it twice, I can use a power of 2. Okay, let me show you one more here with factoring, and then we'll move on to something else. All right, here's kind of a new one, m to the 6 minus n to the 6. All right, well, 6's are even powers here, so I know I've got a difference of 2 squares. So that's step number 1, difference of 2 squares. How do I factor it? Well, it's going to be m to the 3rd times m to the 3rd. Split those up evenly. That gives me m to the 6th. Then I need a minus n to the 3rd and a plus n to the 3rd. That'll give me my negative n to the 6th. Okay, so that's how you factor a difference of 2 squares. Now we're not done because I can factor each one of these again. So in the first parenthesis here, I've got a difference of 2 cubes. Look back to that notes page where I gave you all the factoring techniques. How do I factor this? Well, it factors into m minus n, and then in parentheses, we're going to have m squared plus mn plus n squared. There's the first one split up into 2. And then my second factor, m to the 3rd plus n to the 3rd, this one right here, also can be factored again because it's the sum of 2 cubes. Well, follow your formula again for factoring this. We get m plus n times m squared minus mn plus n squared. So following those formulas, we can figure out the factors for the sum and the difference of 2 cubes. All right, now we have 4 factors here, m minus n, m squared plus mn plus n squared, times m plus n times m squared minus mn plus n squared. There's 4 factors here. We can't really simplify anything. We can't factor any further, so we're done. This is our answer. We got 4 factors for that one. Okay, now let's apply what we've been working on here to some equations. We can solve equations if they are factorable using the factoring techniques that we just went over. And what you do is you set the equation equal to 0, you get your factors, however many there are, and then you set your factors equal to 0. We're used to doing this with quadratics, but now we've got some higher powered functions, some higher power polynomials. Okay, so this one's a degree 4. Let's see what we can come up with for the factors. So first of all, I'm going to try to split this into two binomials because I know that x to the fourth can be split into x squared times x squared. Now I'm looking for two numbers that multiply to give me 36 and add up to negative 13. And two of them come to mind right away. 4 times 9. In this case, I just need to make them negative. Negative 4 times negative 9. That gives me positive 36. And if I add them up, I get negative 13x squared. Okay, so there's my two factors. X squared minus 4, x squared minus 9. Now, 4 and 9 are perfect squares. That jumped out at me right away. So I know I can factor again. I don't just have two factors here. I'm going to end up with 4. X squared minus 4 becomes x minus, well, I didn't mean to put that squared there. Becomes x minus 2 times x plus 2. And then the x squared minus 9 becomes x minus 3 times x plus 3, because we're factoring the difference of two squares here. So I've actually got 4 factors once everything boils down here. Now I need to set all 4 factors equal to 0. So x minus 2 could be 0, x plus 2 could be 0, x minus 3 equals 0, or x plus 3 could be equal to 0. And we solve them. Now, it's a degree 4 polynomial, so I know that there's a possibility of 4 real roots, and that's what we have here. X equals 2, x equals negative 2, x equals 3, or x equals negative 3. Okay, sorry about that, got a phone call. All right, so we have 4 solutions here. Now, if you were to graph this, you could also see that these 4 x values are also the x-intercepts on the graph. So you can always check your answer by graphing as well. All right, let me show you one more. We've got x cubed plus 343 equals 0. Now, 343, I want to make sure that it's a perfect cube, because if it is, I've got the sum of 2 cubes and I can factor it. 343 happens to be 7 to the third power. So what I have here is x to the third plus 7 to the third equals 0. Well, follow your formula now for the sum of 2 cubes. It factors like this: x plus 7 times x squared minus 7x plus 49 equals 0. Okay. Now, of course, you want to check to see if this trinomial factors again, but you can convince yourself pretty quickly that there are no factors of 49 that would add up to negative 7. The only factors of 49 are 1 and 49, or 7 and 7, and they don't add up to negative 7, so I don't need to waste my time trying to factor again. From here, we're going to set each one equal to 0. So x plus 7 equals 0. If I subtract 7 on each side, x equals negative 7. There's one root. That would be easy to see on the graphing calculator as well. Over here, I'm going to need to use a different method to solve. And the one that I like to use if I'm solving a quadratic that doesn't factor, I like to use the quadratic formula. So let's go ahead and do that. We've got x equals, our solutions are equal to negative b, that would be negative 7, plus or minus the square root of b squared minus 4 times a times c. And of course, we've got negative 7 for b, 1 for a, and 49 for c. And all of that's divided by 2 times a, so 2 times 1. Now remember, we're going to simplify this in 3 pieces. First, simplify the negative 7. Always fix this double negative, so it becomes 7. Then we've got plus or minus. Let's figure out what's underneath the square root sign here. If you simplify all of that, you get the square root of negative 147. And then we're dividing by 2 times 1, or 2. So you simplify it in 3 pieces. 1 piece here, 1 piece under the square root sign, and then your denominator. Now, does the square root of 147 simplify? Well, we actually can divide 147 by 3, and we get 49. 49 times 3. So if I think of this as the square root of negative 49 times the square root of 3 I can simplify this fraction. So we've got 7 plus or minus. Now, of course, we know the square root of negative 49 is 7i. Remember, any square roots of negatives are imaginary numbers. The square root of 3 can stay there underneath the square root sign, and then we're dividing by 2. This is about all we can do. This is kind of where I would leave my answer here. So it's a degree 3 polynomial. We've got one real solution here, one real root, and then we've got 2 that are imaginary. Remember, you get 2 solutions here by splitting up your plus or minus sign. So 7 plus 7i squared root 3 over 2, and then 7 minus 7i squared root 3 over 2. This right here represents the other 2 solutions. All right, now I've got a couple for you to try on your own. Bring them to class with you tomorrow. You can use the same kind of factoring that I just went over in the last 2 examples.